let's talk about the next lecture in our course, which is about quadratic equation. Now, this is a pretty large lecture, so I'm going to split this lecture into two parts. In the first part, we're going to talk about the quadratic equation. In the second part, in this lecture, we're going to be talking about the quadratic curves, or more specific, we're going to be talking about parabolas, which are the specific type of quadratic curves. So quadratic equation, what's a quadratic equation? Well, if you remember, we started talking about the linear equation at the very beginning of our story about equations. We said that a linear equation is something that looks like this. So it has this kind of format. So you have something time x plus another number, and that is equal to 0. That's the standard format, which basically means, in general, when you consider what is a linear equation, is something that has a terms with x and terms with a constant number, and that's pretty much the only type of a terms you can have. So if we add a quadratic term to that will change a little bit. So we're going to get something like something with a square. And then, since I'm going to keep this, the coefficient, the multiple of a square a, I'm going to call this the multiple of an x, just b. And then I'm going to have also some constant. So now I have something that looks like quadratic equation, or a format of quadratic equation. This format is called standard format. Since I'm asking to have an x squared, I will require that a is different than 0. So I'm going to have something like this. Right? So I have some term with an x squared, I have a term with an x, and I have another number attached to that. And so this is a quadratic equation. The format, the standard format of quadratic equation. So I have a term with x squared, I have a term with x, I have an extra number, a constant term, and that is on one side, on another side is equal to 0, and I'm asking that the term with x squared be significant. So I can't have it 0. I can't have this 0, so then I would have a linear equation only. Right? So that is what we would call a quadratic equation. But in general, we're going to allow a little more freedom here. So we're going to allow to have this to be not written in this format, but to be written in a format that can be equivalent to this format. So this is the story we had in the past. When you have something equivalent, it isn't necessarily going to be looking like this. It might be a little bit different. So, for example, I could have something like x squared equal 2x minus 5, right? So this is not written in the format of a quadratic equation, but it's more like with the terms on both sides. I might even add something here like that. So I have a term with an x squared, I have a term with an x, I have another term with an x, I have some constant number over there. So I have stuff that does not necessarily look like anything remotely close to this format that we call a format of quadratic equation. It's standard format. It's a standard format. It's term with an x squared, term with an x, a constant term equals 0. One term with an x squared, one term with the x, one constant term, and 0. So I have something else here, right? But again, this is something I can turn into this format. How? Negative x squared. So I have that. I have the 3x. I can put this 2x on this side. It's going to be 3x minus 2x. So I get plus x. and I can put this one on this other side, so I get plus 5. So all of a sudden I have this standard format. So again, the quadratic equation is in the standard format when it's written like this: a term with an x squared, a term with an x, a constant number, all of that other on the one side, on the other side 0. Left side or right side makes no difference. The equation written like that could be equivalent to quadratic equation in the standard format is also going to be called quadratic equation. And this could be all sorts of, we could have, here is another example. Doesn't look like a standard format. It's certainly not a standard format of quadratic equation. It doesn't look like anything that I just mentioned is a quadratic equation. It looks actually completely different. Right? I have the variables in denominator, which is sort of what we call, just recently we call that equation with rational expressions. And this is the type of equation that we have a little bit of a problem with solving, because we were not allowed to multiply with something that we don't know what it is. But we are allowed to multiply with something that is not 0. And I know this is not 0, because this x squared is actually something that could be, at the worst case, it could be 0, right? It cannot be negative, I know that. So if I add 1 to that, I'm definitely going to get something bigger than 0. Something different than 0. So I can multiply with this. And if I multiply with the x squared plus 1, then I cancel this one. I got 5 times x squared. So I'm multiplying with x squared plus 1. So 5 times x squared, which is 5x squared, and then 5 times 1, which is 5. And now I can subtract 1 from both sides, so I get 5x squared plus 4. I'm having a hard time to work with my dry erase markers and erasers that seem not to be erasing and not to be writing properly. All right, let me try this one. So I have 5x squared plus 4 equals 0. Now I have a quadratic equation. So again, I have the number of x squares, 5 of them. I don't have any x's. I'm not requiring that b is different than 0. B could be 0, so the number of x's could be 0. So I don't have any x's there. If you want, you can write it 0x plus 4. So all of a sudden, this equation is actually equivalent to this equation, which is quadratic equation. So that's good. All right. Now, what are we interested in when we're dealing with the equations? We are interested in solving them. So, if you are interested in solving quadratic equation, you have a couple of different methods you can use. All right. Solving quadratic equation. The first method you could use is called factorization method, by factorization. So by factorization. This sounds like something new, but it isn't. It's just by utilizing zero product property. So if you know what a zero product property is, you could apply that, and that is going to be a method by solving quadratic equation by method of factorization. So here is an example. I have this one. It's an example 3, I think, in the lecture. Let me make sure. Yeah, example 2. Sorry. First of all, you have to turn this into a standard format. This is the first step in applying zero product property. You need to have a 0. So the standard format has a 0. You can see that here, right? So I'm going to multiply this to get rid of parentheses. I have 3x squared. 4 times x is 4x. And I'm subtracting 7 now. So that is all on the left side, and on the right side I have 0. So I just turn this into the format of standard format of quadratic equation. The next step is the factorization itself, or you have a zero, now you need to have a product, right? Zero product property. So this is not too hard to do. You have an x and 3x, and by trial and error you need to find two other numbers that would work here. You have a couple of options here. You need to have negative 7s. You can get that 1 times negative 7, negative 1 times 7, 7 times negative 1, or negative 7 times 1. One of those options might work, so you have to check each one of them. This is a trial and error story, and I think it's going to work by having a negative 1 and positive 7 here. So you can check the middle term. This is negative 3x, this is positive 7x, 7x minus 3x is 4x, and of course the rest is also something you need to work. So I have the x times 3x is 3x squared, and the L is FOIL, right? The L is negative 1 times 7 is negative 7, so this works. Okay, so I just factorize this. So the first step is to get the zero product property, then the product, or the factorization, and then you have alternative. This is equal 0, or this is equal 0. If x minus 1 is equal 0, then x is equal 1, or 3x plus 7 is equal 0, which makes 3x negative 7, which makes x equal negative 7 thirds. I didn't write this nicely, so let me do a little better job. Negative 7 thirds. So this is the first solution, this is the second solution. This is how we often refer to that. First solution and second solution. So you have two solutions. Okay? Works nice. Very simple business. Okay, let me do one more example. So now I have another one that is not written in a format, in a standard format. Three x squared plus x equal 10. Again, I'm going to use the zero product property. So the method by factorization is actually zero product property story. I need 0, and then I need a product. So again, you have 8 options. You're definitely going to have an x and 3x, because you need to multiply first and first to get 3x squared. Now you need a negative 10, 1 negative, 1 positive. You have options like 1 and 10, so 1, negative 10, negative 1, 10, 10, negative 1, negative 10, 1. Also 2 and 5. 2, negative 5, negative 2, 5, 5, negative 2, negative 5, 2. One of those 8 options is going to work. I know it's going to work because I made it up, so I know it's not a prime. This is not a prime. So I already know what works here. It's going to be negative 2, positive 5. Reverse, sorry. Well, positive 2, negative 5. Okay? First time first is 3x squared. 2 times negative 5 is negative 10. Works perfect. This is 6xi, and all is negative 5x, which gives you 6x minus 5x, and that is obviously an x, and that's the middle term. So middle term check as usual, right? And now you have product, 0, 0 product, property. The first one is equal 0, which makes x equal negative 2, or the second one is equal 0, which makes 3x equal 5, and that makes x equal 5 thirds. So again, you have one solution and one more solution, two solutions. Alright, so these are two solutions quadratic equation. So this solution here and this solution here. This is the general idea how to solve the quadratic equation factorization. It will involve your skill about being able to factorize something. Now you studied that, so uh, to factorize should be a part of your knowledge already. So this is something you should be able to do. Okay. Now this method is generally not going to work. Okay. And I can give you one example, and it's definitely not going to work. And it looks very simple, but you can't do nothing about it. It's kind of difficult in this example to work with. It's this one here. 4x squared equal 4x plus 11. Okay? Now you can do this in the standard format, so which means you're going to move both of these terms on this side. You get 4x squared minus 4x minus 11 equals 0. And you can try as hard as you wish, but there will be no chance of factoring this. You already have a 0 on one side, so you just need the product. So you have to factor this. This is a prime. You cannot factor this. Not even with fractions. It basically means the zero property is not going to work. You will have to do something smarter. Okay. So I intend to solve this, but let's leave it for a moment out. I'm going to do something much simpler. This second method is called by completing a square. So method by completing a square. So let me give you one very simple example. So I intend to work on this example over there, but I don't want to spend time on that now because it's a little more difficult to work with. So I'm going to do one example that is very simple to work with. The following example. Okay. Now this example, actually, I'm going to put here plus. It doesn't make any difference here. The solution will be slightly different if I have a negative. So you want to try that yourself. So I have this example, and I know that I can solve this easily by factorization. See, what I have here is an x squared plus 6x minus 7 equals 0. I can factor this easily, which is x minus something that whose product is negative 7, and the sum is 6. So it's negative 7 and 1. Oh, positive 7 and negative 1, sorry. And when you make a product of this, you get negative 7. When you sum this, you get 6. So this is a good old story. We have that very simple factorization. So this is now product and 0. So you have 0 property. Says the first one is equal 0 if x is equal negative 7. This one is equal 0 if x is equal negative 7. Or x is equal 1. And in that case, it's this guy. This guy is equal 0 when x is equal 1. So you have two solutions. Okay, so this was really easy to do. Okay, my point is here, I'm going to do this by completing a square. And you can say, why you want to do it by completing a square when it's so easy to do that by factorization? Because of that. I want to have some easy examples. You can see how the completing a square works. The difference between these two methods, one method is by factorization or zero property, the other method is by completing a square, is that the second one works always, while the first one works only if you don't have a prime in the standard format. If you have a prime in the standard format, now this is not a prime, if you have a prime in the standard format as the previous example I had, then this is not going to work, the first method. Well, the second method will work every time. So the second method is universal method. The first method is when you have something you factorize, then it works. When you have something that you cannot factorize, as in primes, it's not going to work. Okay, so how does completing a square works? Well, you're going to have to complete the square. It's easy to say, right? This is the story. So I already know what the solutions are, but I'm going to erase it. I'm going to find it again by a different method. You're going to use this. When you are squaring a sum, you get a square of the first term, which is an x squared. You get the 2 times the first term times second term, first term times second term, or second term times first term, makes no difference. And then you're going to have the square of the second term. Now this is the story we had a long time ago, but I wrote it like this. A plus b squared is equal a squared plus 2ab plus b squared. The only difference I'm making now is that I'm calling the first term x as opposed to a, because that's what I'm going to use there. Right? So that's what you need. This is a trinomial that is a perfect square. This is the square. Okay? So now, that's what you need to make here. Now this is definitely not a perfect square, because you need to have something positive here. This is negative 7, so there's no way that this is looking like a perfect square. You can make it. What you're going to do is you're going to move this guy, which is kind of violating your intentions, to the other side. So you get the x squared plus 6x equal 7. So 7 is not good, negative 7 is not good. Something that would be good. What would that be? You need something here. You have an x squared. You have 2bx. B is 3. This is 2 times 3 times x, 6x. So this is your b. So you need the b squared. I'm adding this to the left side, but if I want to keep everything equivalent to what I had before, I need to add that to the right side as well. And you keep the equation equivalent if you add the same number to both sides. Now I have a perfect square. This is a perfect square. It's a square of x plus 3. Again, use this format. X squared here. 2 times this times this is 6x here. This square here. What you have on the other side is just 16. You have 7 plus 9. So that was a very important step. Now you have to think, how do you get a square to be 16? You can think about radicals. What's a radical 16? 4, of course. X plus 3 is equal 4. And you can say, I'm done now. Actually, you're not done, because there's another number whose square is 16. And that another number whose square is 16 is negative 4. So you have or. X plus 3 being negative 4. So you're not really looking for a radical. You're looking for a number whose square 16 is. One of them is radical 16, which is 4. Another one is negative radical 16, which is negative 4. And now you can finish it. So you have here x obviously must be 1. 1 plus 3 is 4. On the other side you have to subtract 3. So you subtract 3, get negative 7. x2 is negative 7. And that is what we get as two solutions. So we had that before when we were doing the same problem by using a method of factorization, solving quadratic equation by using a method by factorization. Okay, so now this is the idea we're going to use. Okay, this is a very simple example though. So in general, you're not going to get example this simple, and if you get them, you probably want to use the method of factorization rather than completing a square. Why bother completing a square when the method by using a factorization is going to be simpler? Okay? To choose the simpler method rather than the more complicated method. Okay, but sometimes you do really have to use the completing the square because the factorization method by factorization is not going to work. right? So that leads me again to that previous example I had, which was 4x squared equal to 4x plus 11. And I already said uh, you can turn this into standard format, and now you can try to factorize, but you will not find a factorization because there is no factorization here with integers, not even with fractions. So the only thing you can do here is to use method of completing a square. Okay, so how is that going to work? So the same thing I was doing moments ago. You're going to leave the x's on one side. Which means you bring that 11 on the other side. So if I was following my intention right from the beginning, I would not move this one on the other side. I did that just to see whether I can actually factor this, and then I conclude, you can try yourself, that there is no any chance of factorization here. So now I'm doing the completing a square method. So the first step is to get the x's on one side, to get a constant term on the other side. You can remember that. The second step is I need to have the x squared here. Now if I have an x squared, that'd be great, but I do have here 4x squared. I need 1. Look at my format here. I need 1. That's easy. Divide with 4. So the whole thing is going to be divided with 4. You divide this with 4, you get an x squared. You divide this with 4, you get negative x. You divide this with 4, you get 11 quarters. Now that's a fraction, and it's not attractive, but it will stay. If you have to deal with fractions, you will have to deal with fractions. There's nothing better you can do. The solution could as well be fractions, so you can't escape it. Okay. Now I need to find the third term here to complete the square, to get a perfect square. So I need this. I have x squared, I have 2bx. This is 2b. And I need a b squared here. If 2b is negative 1, then b is a half of it. So you just basically need to make a half, or whatever you have here. And there's your b, negative 1/2. That must be added, but not just negative 1/2. You need to square it and add it. B squared. So your b is 1/2, negative. And you also have to do it to the other side, because you want to keep equivalent equation, right? You're adding the same number to both sides. Okay, now the rest of the story. This is now a perfect square because it matches this side here. So what it is x plus b squared. B is this guy. So you have an x plus b, x plus minus 1/2 squared. Okay, always try to convince yourself that check whether you have what you need to have. Square, you got here. 2 times this, you got here. Square this, you got here. On the other side is peanuts, right? You have the 11 quarters and 1/4. This is 1/4. You square the 1/2, you get a quarter. And negative times negative, of course, is going to be positive. So you're going to have 11 quarters and 1/4. That would be $3, right? 12 quarters. So that's the right side. It's not really that hard. What is the next step? The next step is to think about it. What is the radical here? What is the number here whose square 3 is? Well, one option is radical 3. And the other option, of course, is negative radical 3. Because when you square negative radical 3, you will also get 3. And now I just need to add 1/2 to both sides. So you have x is equal 1/2 plus radical 3. This is the first solution. And the second solution is 1/2, this one on the other side, negative radical 3. And you can ask, can I approximate this? And the answer would be no, you can't. You have to leave it the way it is, because we are looking for exact solution, we're not looking for approximation. But if you really need approximation, you can say this is approximately 2.23. You can use a calculator. That one over there is approximately 1.23. But this is the best way you can write it. What is this? Well, there is some number whose square 3 is, and you add 1/2 to that. That's what this number is. 1/2 more than number whose square 3 is. So that's an explanation. There's nothing better you can do. This is not a fraction. It's an irrational number. It's not a decimal number. So this is the best way to write it. And that one over there is also the best way to write it. They're not the same, they're different. This one has a plus, this one has a minus, right? And, okay, oh, excuse me, I forgot to say, this one is negative 1.23, not approximately. But we'll leave it this way. This is perfectly good. So, okay, let me review this one more time. So this is, I was solving this equation in the beginning by using the completion of a square. I was completing the square. Okay? First thing you need to do is to get the x's on one side. So this is the first step. X is on one side. That constant is on the other side. Second step is you need to get a single x squared. I accomplished that going from this step by dividing both with 4. Right? The third thing you need to do is to complete the square. So I'm going to do the next line. I did it in the same line here. We're going to do the next line here. So you got this guy. You take the half of this number here, which is 1/2, and you add that as a square to both sides. So that's the third step. Very important. That is actually completion of a square. You are actually achieving a square here in this format. What square? This square. So you have x squared, b squared, this is b squared, and 2 times b times x. This is 2 times b. So this is 1/2 of this, or this one is 2 times this guy. You will find this guy by making a half of this guy. So 2 times b times x. 2 times this guy times x is right here. So now you have x plus b. You can remember what x plus b is. X minus 1/2. X plus negative 1/2. And on the other side I had these 3. 11 quarters and 1/4. The rest of that is thinking about radical. So the rest is easy. But let's call it step number 4. You either have this to be radical 3 or negative radical 3. So that's the first step. Again, the first step, x is on one side, the constant on the other side. The second step, peel everything around x. You need just an x squared. X squared. So you're dividing the whole thing with 4. This one divided with 4, this one divided with 4, this one divided with 4. The third step, completing a square. Make a half of this guy, add it as a square to both sides, because you want to keep it equivalent. And then the fourth step is, once you complete the square, this is a square. This is what it is equal to, as a square. And now you have the story about how how can the square be 3? Well, you either have a radical 3 or you get negative radical 3. Both of them have a square 3. Okay? I am sure you have heard of something called quadratic formula. That is something everybody learns in elementary school. So I am positive you have seen this, maybe you forgot what it looks like, but I'm going to write it for you. So you can write that this is a third way of solving the quadratic equation by quadratic formula. So you have the solving by factorization, solving by completing a square, and solving by quadratic formula. A quadratic formula is x1, 2, two solutions, possibly. Negative b plus minus b squared minus 4ac under the radical divided with 2a. In case you have the quadratic equation written in a standard format, which you have to have, so you need to know what the a, b, and c are. So you might think about, okay, this is something I've seen before. It's the easiest way to solve quadratic equation in a universal way. Yeah, factorization is easier, but it's not universal. When you have prime, you can do nothing about it. But this one works every time. Okay? So I'm going to give you an example how it works. And I'm going to, after that, I'm going to try to convince you that this is actually nothing new. So here's the example. You could solve this by completing a square. You could also do this by factorization. I have some very simple example. As a matter of fact, factorization is relatively easy. So you have 3x and x, and you have let's see, I need to get positive 1 here and positive 7 and negative 1, sorry. And that's equals 0. It's a factorization. And so now you can check this out, it really works out, but let's say just middle term check is negative 3x, positive 7x, that will be 4x. So it works perfect. So I have two solutions. When this is equal to 0, or when this is equal to 0. And the second one is peanuts, right? X must be 1. This one, 3x must be negative 7, so which means that x must be negative 7/3, a third of negative 7. So you have two solutions, the first, the second. Okay? By factorization. I'm going to also do it by completing a square. Let's see, completing a square. Put this guy on the other side. Divide with 3. We need to get a single x squared here. Everything has to be divided with 3, right? So dividing with 3. Now, you need the half of this guy squared here and here. Half of any fraction is double the denominator. You go 4/3, the half of that is going to be 4/6. 3/4, the half of that is going to be 3/8, which is double the denominator. Half of this is this guy. But you have to square it. And now to both sides. obviously, you can make it a little simpler. 4 sixths are going to be 2 thirds. I could have been a little smarter. I could just think about it. 4 thirds, so half of that is 2 thirds, right? But again, if you cannot half the numerator, I could, because half of 4 is 2. If you cannot half the numerator, you double the denominator. So I'm still in the process of making a square. Or should I say, completing a square. Right? So now I know. A, B, so I have dx plus 2 thirds squared. And again, the square of this guy is right here. The square of this guy is right here. 2 times this is 4 thirds x, which is right here. This is a perfect square. I have completed a square here. On the other side, you have to work this out a little bit. What you have here is 4 ninths. What you have here is 7 thirds. You multiply up and down with 3, it's 21 ninths. So you have 25 ninths. I know you're gonna spend some time to convince yourself this is so. Work it out. I'm sure you can work with fractions. Now, the question is, how is this gonna be equal to that? What number that is here to square 25 over 9 is? Well, that's easy, radical. X plus 2 thirds is equal radical 5 over 3, or x plus 2 thirds is equal negative 5 over 3. The both of them squared will give you square this, minus times minus is plus, 5 times 5 is 25, 3 times 3 is 9, right? Now, subtract 2 thirds. You subtract 2 thirds from 5 thirds, you get 1. You get 3 thirds, right? You subtract 2 thirds from 5 thirds negative, you're going to have negative 7 thirds. So this is second solution. So I just did solve this equation by completing a square. So factorization, completing a square. Now you're definitely going to say this is so much easier here. Yes. The problem is the factorization might work and might not work. Completing a square always works. So that's why this method is important. If something always works, that's the method you want to use, right? You get an emergency in a hospital, and somebody tells you, well, we have this medicine that works really nicely and fast, but for some people it doesn't work, so they die. Do you want to try that? Or we have another medicine that works a little more painful, but everybody gets saved when they use it. What would you choose? Right? I don't think anybody will have any doubts. So the same thing here. Completing a square is a better method in general because it works always. But you can also use quadratic formula. So this is now one more method. Okay, you need to find out A, B, and C. That's easy. A, B, C. And then you use the formula. Plug it in. This is how you plug it in, right? You probably don't remember, we were talking about that many times before. You do have to use containers. Oh, gee. All right. Finally, to get things going. All right. We'll want to use this one further on. All right. So what do we have? A. Let's say 3. A. C. that's how you do. You do containers first, replace the label, and then put the value in. If you don't do that, the tendency is to make a mistake. Right. Now this is really not that hard. 16 plus and minus plus 84. 1684 is 100. So I cooked this nicely so I know it's easy. Negative 4 plus minus a radical 100, and down there we have clean 6. Okay? Now the positive radical 100 is 10. 10 times 10 is 100. So you have negative 4 plus 10, which is 6, divided with 6. So that's the first solution for plus. Maybe we want to put it like that so nobody thinks you have some thousands there. Anyway, the second solution for minus. So you get negative 4, negative 10, which is negative 14. Negative 14 divided with 6. You are going to probably want to reduce this. So you divide up and down with 2. And you get 7 over 3. Negative 7 over 3, the second one, the first one 1. Doesn't make any difference what you call the first one, what you call the second one. So this is how it works with quadratic formula. Again, factorization is the easiest if it works. Quadratic formula is easier than completing a square. And now the next question is, why do I need to know completing a square when quadratic formula is easier to use? Two reasons. One reason is that quadratic formula is really not a new method. It's actually the end of the story of completing a square. So when you're using quadratic formula, you're actually completing a square. What's going on with this board? I have to replace the board now. All right. This is how it is. So you have your good old quadratic equation. Okay? If you solve this general quadratic equation by completing a square, you will actually discover quadratic formula. In other words, quadratic formula is simply a plug-in formula that is the end result of completing a square. So, see you on the other side. Divide with a, because you want to have an x squared. Not ax squared, but simply 1x squared. Now, a is different than 0, so you can divide with a. You're getting an x squared. You're getting a, why am I writing c here? I have no idea. It should be x, right? Divide with a. Divide with a. Okay? Now, I need here a third term to get this nice square. So, I need to halve this guy, square it, add it here, and add it here. That's a half of this. Double the denominator, right? I already talked about it. Anytime you need to make a half of a number, there is a fraction. If you can make a half of this, great. But if you cannot make a half of this, just double the denominator. 3/8 is a half of 3/4? Not too difficult to see that, right? I hope not. So that's what I'm doing here, making a half of this and squaring it and adding here and adding there. So now I know that I have a perfect square here. It's an x squared, x plus b over 2a squared. I need to work this thing out. It's really not that hard. It might take some time, you know, to figure this out. So I have c over a plus b squared over 4a squared. When you square that, then I need a common denominator for a squared, for ac. When you cancel 4 and 4, then a, you got c over a plus b squared over 4a squared equal. I forgot one more thing here. When I move this one to the other side, I get negative here. So that ought to be another thing here. I just noticed that I need that minus. So I have minus here as well. Minus. Minus. And add now. I'm going to put plus forward. So I get a b squared minus 4ac divided with 4a squared. Hey, I'm shaping up this formula. Some pieces are coming together. Okay, let's just write it over there. And next thing you need to do is to take a radical, or to find what you need here. Let's take a radical. So we have x plus b over 2a equal radical on the top. Nothing you can do. Keep it that way. With a radical, of course. The bottom, you can do the radical. It's 2a. That's one. But then you have the other one with minus, right? So, or x is equal, I should say x plus b over 2a is equal to negative. Again, the same stuff, b squared minus 4ac divided with 2a. And the only difference between this and this is that I have here plus and I have here minus. So I might as well put it together and write plus minus. And that's exactly what I'm going to do. X plus b over 2a is equal plus minus radical b squared minus 4ac divided with 2a. But there are two formulas, so one for one solution, one for the other solution. And the next step is obvious. I need to get rid of this piece here. So I'm going to have x1, 2 equal negative b over 2a plus minus, alright, b squared minus 4ac divided with 2a. And good looking fractions because they have a common denominator, so I could just simply add them. And this anymore, I need some space. I have x1, 2 equal, add them, common denominator, the first numerator minus b, the second numerator plus minus b squared minus 4ac. So quadratic formula. So quadratic formula is a result of a completing a square in a general standard format with A, B, and C, not particular numbers, but with those A, B, and C's. Okay? Again, I'm not going to bother you with this in the test. I'm not going to ask you to show me how this follows, but you're going to have to remember that. To remember that quadratic formula is nothing but a completing a square in general format. But you don't really have to complete a square, you can just simply plug in. So the advantage is you have a plug-in procedure. And plug-in procedure, of course, is much easier than to work the whole thing yourself. Right? It's something that is prepared for you already. Mold is there, and instead of, you know, making that yourself, you get a mold, you just put it in a mold, and everything is done for you. That's a nice thing to have. Okay, well, more about quadratic formula. We have something here special, this radical, and we call this radicand b squared minus 4ac. Discriminant. That's why I label it D. We call the discriminant b squared minus 4ac, we call that discriminant. So you have three things that could happen here with discriminant. Discriminant could be bigger than 0. So if this radicand is bigger than 0, you're taking a radical, you're going to have something, then you're going to have one solution for plus, one solution for minus. You're going to have two real solutions. Quadratic equation has two real solutions. The second option is that D is actually going to be 0. If D is equal 0, this guy is equal 0, so you end up with x1, 2 is negative B plus or minus radical of 0, which is 0, divided with 2a. This is very simple. And it's only one solution. You don't really have two solutions because you just have one number here. So the quadratic equation has one real solution. And you can immediately write that negative b over 2a. You're done. And then you have a third option. Discriminant could be negative. If discriminant is negative, this radical will be negative number. I mean radical of a negative number. Radicand will be negative. And that, you can say, okay, now I don't have any radical. Yes, you do. Actually, you do have a multiple of I. You get a complex number. So you get a complex number here, and you combine with the rest of this, is going to be complex number. One for plus and one for minus. So the quadratic equation has two complex solutions. I'm going to show you that in a moment. I'm not talking about two complicated solutions. I'm talking about two solutions that are complex numbers. Okay? So let me give you an example. It looks very nice, but it turns out to be something that is not so nice to work with. idea you're going to have, well, I'm going to factorize this. I can factor this. You will not be able to. It's a prime. On the left side, it is a prime. It is not possible to factor. You can try, but it's not going to work. So factorization is off. You can also try to do the completion of a square. Or you can do the quadratic formula. It's one of the same, right? We just mentioned quadratic formula is just a shortcut to completing a square. So let's do quadratic formula. What do we have? A is equal to 1. Number of x squared is one of them. B is the number of x's, which is 2. The number of x's is 2. And C is obviously 6. So this is also simple. 3 integers. How hard this could possibly be. And then quadratic formula. Okay? The quadratic formula works this way. Minus b plus minus radical b squared minus 4ac, I'm using containers, divided with 2a. A goes on 2 places, here and here, and I have 1. C goes on 1 place, here. And B goes on 2 places, here and here. So I'm just filling up this formula. Replace the variables with containers, place the value of variables 1, 2, 6 in containers. And the rest is easy. Or should it look easy? I don't know. Negative 2 plus minus. What do we have here? It's 4 minus 24. This is 4 times 6, 24. Minus 24. 4 minus 24. It's negative 20. Divided with 2. So you can say, oh, I'm done here. I can't go any further. No, actually you could go further because you have at this point some knowledge about complex numbers. So that radical of negative 20 is a complex number. How? Well, this is what we do. Radical of 20 negative is radical of 4 times 5 times negative 1. You have 3 factors here. 4, 5, and negative 1. Now 4, so now you split the radical, right? Radical of 4 is 2, because these are factors. 1, 2, 3. Something times something times something. The radical property says that you can split the radical or distribute the radicals onto factors. Radical of 4 is 2. Radical of 5 is radical 5. Nothing better you can do with that. It's a rational number. Radical of negative 1 is I. So now you have it. So continuing this, I have 2 plus minus 2 radical 5 I. I don't have to have that much of an umbrella here. Let's put it this way. I just want to close this radical sign because I don't want you to think I is under the radical. Just the 5 is there. And then I have 2 downstairs. One more step. I have a common factor 2 on the top, right? You have 2, you have 1, plus minus 2 common factor out, radical 5i. Divided with 2. Cancel, cancel. And you have 1 plus minus radical 5i. This is 2 solutions we were looking for. 1 for plus, 1 for minus. And it's not attractive, I know. Its solution has 2 complex numbers. The first one is for plus. Real part is 1, imaginary part is radical 5. The second complex number is for minus. The real part is 1, imaginary part is negative radical 5. That's what it is. It's not a nice number. It involves complex unit I and it involves irrational number radical 5, but that's the best you can get. this is not looking so bad. It looks very nice, actually looks very simple, but the solutions are not so simple. Okay, so again, we have learned something about the quadratic equation. This is the equation that is equivalent to this format, and we can solve the quadratic equation in three different ways, basically two, but you can say three. One is by factorization, which is a zero product property. The other one is by completing a square, which is a very important thing to do, and you're going to learn that in the second part. Actually, I'm going to show you again completing a square is an important thing to know. And then you can also use a quadratic formula, which is something that is really readily available. You can just plug it in. It's a plug-in procedure, but make no mistake about it. This quadratic formula came out of completing a square, and the guy who came up with that formula that we already have mentioned was that same guy we had in the past from 17th century, René Descartes. We mentioned this guy as a person who made that XY plane, Cartesian plane. He also come up with this. So that's 400 something years ago. So he came up with a way to write it down in a nice way. He was not the first one that was able to solve this. So Persian mathematicians were able to solve quadratic equations. Another Frenchman, Francois Viet, come up with another formula, a lot more complicated though. Even Chinese mathematicians had the formula to do that. But he came up with this formula. This formula we even use today. So that must be the simplest formula to remember. And you do have to remember it. So that's another way to do it. Of course, he was completing a square. Right? Okay, this is the first part of the story about quadratic equations. We're going to actually do the second part, which is going to be where do you see that in the story about geometry? Because we had the linear equations connected with the lines. So quadratic equations are also connected with curves in plane. And so that's the next story. And that story we have the next time on the streaming lecture. So this is done. You can start working on the homework. The homework for quadratic equation is long homework, and it has that suffix EC as an extra credit. That's how I'm going to calculate it in your grade, but it's not an extra topic, extra credit topic. It's actually regular topic, and you have to really study it because it's going to be a prominent thing on the next exam, number 4, and in the final too. So it's not something that is an extra credit topic. It is just the way I calculate the homework. But you have to work on that homework, okay? You can start working now, but we're going to do a little more in the next streaming we do, okay? So I'm going to end up this lecture.